In this lesson, you will learn how to add and subtract polynomials. Polynomials are expressions that contain multiple terms. For example, the expression 2x squared plus 4x minus 6 is a polynomial expression. As you can see, there are terms that have exponents, so we have x squared, you have variable terms like 4x, and you have constant terms like 6. On top of that, you have coefficients like 2 and 4, which are multiplied by the two variables. So this is a polynomial expression, and I'm going to show you how you can add and subtract two polynomial expressions. Something that's important when you want to add or subtract polynomials is you need to be able to identify and combine like terms. Now, like terms contain the same variables raised to the same powers. For example, if you had the terms 2x squared and 1.5x squared, these would be like terms because they contain the same variable of x and they're raised to the same power, which is 2. Now, for a term like 4x, a like term for 4x would be something like negative 3x. Same variable and it's raised to the same power. And lastly, all constant terms are like terms with each other. So you have negative 6 here. Another like term would be something like positive 8. Now you can add and subtract terms when they're like. So let's go ahead and look at a problem together and we'll see how this works. So here we have two polynomials and we want to find the sum. Now the first thing to do is to rewrite this addition sentence by putting like terms next to each other. What that means is you're going to have to pay attention to the signs of the like terms when you start moving things around. And I'll show you what I mean as we do this. So notice here you've got 2/5 x squared, and this lines up with the 5/3 x squared. Same variable, same power. So these are like terms and we're going to write them right next to each other. 2/5 x squared, and we have a plus, and this is also positive. So plus 5/3 x squared. Now, let's take a look at the next term. 3x, and the common or like term for 3x over here is negative 3/5 x. So we're going to have positive 3x plus negative 3/5 x, which is the same thing as subtracting 3/5 x. Okay, so now we've got those two terms next to each other. And then lastly, we have a constant of positive 7. And we're going to add that to negative 1/3, so we're going to subtract 1/3. So now we have all of the like terms next to each other. We can begin to add. So the first step is, let's work with these x squared terms here. We have 2/5 and 5/3. Because these are fractions, we need them to be like fractions to add. So let's do that work over here. We need to take 2/5 and 5/3 and turn them into like fractions. Well, the least common denominator between 5 and 3 is 15. So I'm going to multiply the top fraction by 3/3, which will give me 6/15. And down here, I'm going to multiply, oops, sorry, not equals yet. Let's erase that. Down here, I'm going to multiply by 5/5 to get a denominator of 15. So this gives me 25/15. So now that I've rewritten these fractions as like fractions, I can go in and rewrite the problem. So 2/5 was changed to 6/15 x squared, and then you're going to add that to 25/15. And we're just going to do all the math for combining the like terms separately, and then we'll put it back together in one large expression. So 6/15 plus 25/15 equals 31/15 x squared. So you keep the x squared the same. Now let's go ahead and take a look at the next terms. We've got 3x and negative 3/5 x. So we have 3, which is a whole number, and a fraction. So we need to turn the whole number into a fraction with a denominator of 5. And to do that, you're going to take 3, and we're going to put that over 1, because that's how you represent a whole number as a fraction. 3/1 times 5/5. And this will give us a denominator with a fraction of 5. You get 15/5. So now we have 15/5 x minus 3/5 x. 15/5 minus 3/5 leaves you with 12/5 x. Okay, we'll keep track of that as well. Now let's go ahead and look at the last thing we've got. We have 7 minus 1/3. So again, a whole number and a fraction. So we need to convert this whole number. 7/1 times 3/3, and I'm multiplying by this because we want the denominator to be 3, gives you 21/3. So now we have 21/3 minus 1/3, which equals 20/3. So now we have the three sums that we found, right, from the different parts of the polynomial expression, which means we can rewrite this as the sum of these two polynomials. So putting it all together, you have 31/15 x squared plus 12/5 x plus 20/3. Now, if you want to write these fractions as mixed numbers, the answer you would get instead would be 2 1/15 x squared plus 2 2/5 x plus 6 2/3. Now, both expressions are correct. It's just different ways of representing the fractions. Okay, now let's try another problem. Identify whether the statement is true or false. So let's take a look at A. It says the sum of x squared minus 3x and 3x squared plus 1/2 x is 4x squared minus 2.5 x. So we've got a couple of keywords to clue in on. So it says the sum of, so we have this first polynomial and this second polynomial is this third polynomial. So let's translate this into an algebraic expression. So what this sentence is saying is that x squared minus 3x, let's put this in parentheses, plus 3x squared plus 1/2 x equals 4x squared minus 2.5 x. Now, to see if this is a true statement or not, what we need to do is add these two polynomials and see what sum you get. So let's do that down here in green. You have x squared minus 3x plus 3x squared plus 1/2 x. Now, again, we want to rearrange this by putting the like terms next to one another. So that would be x squared plus 3x squared minus 3x plus 1/2 x. And let's begin by combining x squared plus 3x squared. So you can assume that this has a 1 here, coefficient of 1. So this is 1x squared plus 3x squared. 1 plus 3 is 4, so this is 4x squared for the sum of these two like terms. Now let's talk about the second part. Negative 3x plus 1/2 x. Negative 3 plus a half is negative 2.5, and then bring along the variable. So this would be negative 2.5 x. So this is the sum you get. And let's see if this matches what we wrote down. 4x squared minus 2.5 x, that's what we got. So yes, this statement is true. Now let's take a look at the second one here we have in B. Subtracting 3x from 4x squared plus 3 gives you x squared plus 3. So now, again, let's focus. We're subtracting, and what are we subtracting? We're going to subtract away 3x from 4x squared plus 3, and we can write that out. So 4x squared plus 3, and we want to subtract away 3x, so minus 3x. Now, what does this give us as a difference? So I'm going to just write this without the parentheses, and we'll write it in decreasing degree, so from the highest exponent to the lowest. 4x squared, the next degree is just x, so minus 3x plus 3. Now let's look for like terms. I see an x squared, but there's no other x squareds in this expression, so this one doesn't have a like term. Minus 3x, there's no other x term, so this is the only term that contains a variable raised to the power of 1. And then you have plus 3. So we can't combine anything here. This is what we're left with. When we subtract 3x away from this binomial expression, you get 4x squared minus 3x plus 3. The statement says subtracting 3x from 4x squared plus 3 gives you x squared plus 3, but that's not what we get. We get this, and this is actually correct, which means this statement is false. In this lesson, you've learned how to add and subtract polynomials. Thanks for watching.